the next problem is to find the nth node from the last in a list. So for suppose they're given n as 3, we need to find the third node from the last. 1 2 3, third node is 6, we need to return 6. So it's easy pretty if you know the count of the list. One way is, if we were given a list, then definitely we need to traverse the list once, that is O of n operation, and find the length. Okay, or if we are making the list, when you add a element, you just can increase, you can have a variable like a length. Initially it will be 0, as and when we add a node we will increase the 1. So when at the end of the list we will have the length of the list. That is one way. Or if we were given a list, then definitely we need to traverse to the list that gives us the O of n time. Anyway, let's assume that we were given a list. So uh, to traverse through the list to find the length, the time would be order of n. And then in order to find the nth node, here the third, for suppose here in this case the list length is 8, right? So in order to find the third from the last, what is the calculation that we have to use? 8 minus 3 plus 1, this is 6, right? 1 2 3 4 5 6. So the last the last the third node from the last is equivalent to the sixth node from the first. That is what it means. We can try this for another one. For suppose the n is 6, so the length is 8 minus 6 plus 1, that is 3, right? From the start third node is 3, and this should be the sixth node from the last. 1 2 3 4 5 6, this is true. So the formula is the length minus n, that is given to us, plus 1. So once we traverse to the list once, we will find the length, that is O of n operation. And in the worst case, for suppose if they asked 8th node from the last, then we will have to, not 8th node, first node from the last, then we will have to traverse through the whole list again one more time. That is one more operation, O of n operation. So finally the whole time would be the O of 2n without any extra space. This is one approach. And again we have the savior two pointer technique, which we can use and complete this in O of n time. I'm going to explain how we do that. 2 3 4 5 6 7 and 8 have 2 pointers as usual. In this case, fast and slow, not fast and slow, the reference and main pointer. There are a lot of 2 pointer techniques. We need to know which technique we need to use to which problem. So here the reference and main, and to find the middle element we use the fast and slow, and to find the to detect the loop in the linked list we use again the fast and slow pointers. And for this thing, what the 2 pointers and the technique which we use is, for suppose they say we need third node from the last, we move one pointer 3 nodes. So let's suppose we are moving the ref first. 1 2 3, we moved 3 nodes to the ref, and now we start moving both main pointer and the reference pointer. This is nothing but we are subtracting the length from the start. This is same as that of the L minus n plus 1. If we see that ref is 3, now we start move the main pointer and the reference pointer. Main will go here, reference will go here. Main will go here, reference will go here. And main will go here, reference will go here. And then main, reference, main, reference. So reference came to the end. and the main is here, and the main points to the third node from the last. Simple. So it's just that these are several techniques using 2 pointers. This is one of the technique. Have 2 pointers and move one pointer to the n node from the first, and start moving both the nodes till the reference pointer reach to the last node, and then main node will be pointing to the nth node from the last. So I'll be coding this out now. So I'm gonna name the function as find nth node from the last, the function or method, whatever. Why I'm saying int is I'm gonna return the data of the node, or if you want to return the node, we can just mention the node. So we'll be returning the node, suppose, and find nth node from last. Okay, we will be given n, and I am assuming here we already have a head of the list, which is, or we were given a head, even that is fine. We'll have 2 pointers, node reference pointer that is initially pointed to the head, and we have one more pointer that is main pointer that is also pointed to the head, and we'll have one more variable that is count. Initially the count is 1 because we already pointed to the head. That means we are in the first position already, first node already. So first we need to move the reference pointer to the n positions. While ref pointer dot next is not equal to null and the count is less than n, reference pointer is equal to reference pointer dot next. We are moving it, and we increase the count as well because we need to move only the n number of times. By this time we will be pointing to the third node from the first, if n is third, 3. Now we need to start moving both the pointers till the last node. So the reference pointer equal to the ref pointer dot next, and the main pointer equal to main pointer dot next. Return this main pointer. That's it. We got nth node from the last.